when we talk about problems that involve shadows, these are called indirect measurements, okay? When we have a problem like a shadow, okay, we are going to use the properties of similar figures because we are creating similar figures with what's happening, okay? The sun, or in that case, the flashlight, is at the same angle for both Matthew and Ellie, okay? Since their heights are different, their shadows are different, but the angle in which their body is to the floor, right? They're making a 90-degree angle with their body in the floor. The angle in which the light is shining on them are creating two triangles that are similar, okay? So if we can draw our picture, we can set up a proportion and be able to solve for either a missing height or, in the case of my example up there, a missing shadow, okay? I do not think that you have to draw the most beautiful pictures in the entire world. They don't have to be super detailed, but we need to be able to figure out what's going on, okay? So, we have a flagpole and a guy named Evan, right? All right. So we have a flagpole and we have a guy named Evan. Okay. The sun is shining and each of these are casting a shadow because the sun is shining. See how that's working? Okay. What is 32 feet? Like, where does this number go on our picture? A flagpole casts a 32-foot shadow. So 32 goes right here. Evan casts a 9-foot shadow. So the 9 is going to go right here. The shadow is...
9-foot shadows.
Yeah.
That's so big. A 9-foot shadow.
You've never, like, looked at your shadow and it's, like, super duper long on the ground? Never? If it's noon and the sun's directly above you, you're not going to have a very big shadow. But if it's, like, 9 a.m., the sun's over here, you're going to have a pretty big shadow. Okay, look at your shadow the next time you're outside. Okay, now where does 6 go? Go on, pass. The up one? Okay. Evan is 6 feet tall. I want to know how tall is the flagpole. So I'm going to put an X right here. How tall is the flagpole? Okay. Anybody have a guess? So how about this? Is it going to be bigger or smaller than 32? It's going to be smaller, okay, because Evan's shadow is longer than how... Okay, we'll see. All right, so we are going to set up a proportion. What corresponds with X?
6.
I'm going to do X over 6. Now, in this fraction over here, am I going to put 32 over 9 or 9 over 32? Why? Okay, since we went from flagpole for our numerator and Evan for the denominator, then we need to take flagpole for our numerator and Evan for our denominator. Okay? In my opinion, drawing the picture and setting up the proportion is the most difficult part. I think you have gotten really good at cross multiplying. We have 9 times x equals, what's 32 times 6?
192.
What?
192.
192? Okay. Then what do? We got to divide by 9 to get x equals. Now, is it just 21.3? Ooh, 21.3 feet. Everything has been a measurement in terms of feet, so we better keep that consistent. Okay. Now, I am totally fine if you, are you watching? If you only draw that. That's fine. If you have 2 triangles and you label them with the 3 pieces of information and X with the missing one, that's fine. If you want to make it look like whatever's happening, the flagpole and Evan, that's cool too. But I am not going to force you to draw a super detailed picture if that's not your jam. Okay? So what I want you to do right now, I want you to take number 2, and I just want you to draw the pictures. So the 2 triangles, where does 4, 36, 7 go, and what's the missing value? Like, label the fourth X, okay? But I want you to draw the 2 pictures and label the numbers, okay? Are you okay?
Yeah.
Okay, are you okay? Okay.
Two stop signs, 2 different sides.
So we have a stop sign and a tree.
How you doing, Frank?
Stop trying to.
Just draw like a flag and then just draw.
Yeah?
Okay, I'm done.
You put the numbers in there too?
Yep.
Okay. So, yep.
So 4 goes.
So the shadow goes always to the ground. Mhm. So, 4. It's beautiful.
It's like a triangle.
Yes. What? That's my tree.
Oh, it's a good tree.
Is it? Is it a good tree?
It's like a big.
Trees aren't my favorite thing in the world.
Okay, where does the 4 go?
On the stop sign.
Stop sign shadows.
On the stop sign shadow, which means does it go vertical or horizontal?
Or vertical.
Horizontal.
Oh, horizontal, sorry.
This is horizontal.
Wait.
On the ground.
7.
Okay, so where does the 7 go, Matthew?
Slide.
Go ahead. Okay, so 7 goes here. Okay. Where does the 36 go?
Tree shadow.
The tree shadow, and we're looking for its height, okay? So at the very least, you have these blue triangles right here. If you have the other picture, cool. If you don't, cool, Okay? At the very least, you need those blue triangles. Okay? So, Landon, give me one ratio that we can set up for our proportion. Like, what does 7 correspond with? Here's 7. What does it correspond with over here? Okay, 7 over x. Write it. Do we write 36 over 4 or 4 over 36? 4 over 36. Solve it. That is an excellent tree.
We're supposed to make a tree?
Okay. So. We are going to do this up. So what I can do is I can do this video. Yeah.
I'm doing this now. What am I getting wrong?
So I have my answers up there in black, 1, 2, 3, 4. Okay, so when we get to work time, I'll check. Okay. You are doing something wrong. Okay, so hey, what's 7 times 36?
252.
So 4x equals 252. And then when we divide by 4, 63 exactly? 63 what? Feet. Okay. Basically, what I need you to do when you have these shadow problems, at the very least, you are going to draw 2 triangles, right? You need to put a measurement for how tall they are, a measurement for how long the shadow is, but of the 4, one of them is going to be unknown. One of them is going to be an X. When we're talking about a shadow problem, we don't ever have to worry about that part of the triangle right there. It's going to be either the vertical or the horizontal, okay? So, like in number 4, you can draw those 2, or you can say, ooh, I'm going to draw a water slide, and then, ooh, I'm going to draw a 4-foot child, okay? You can draw those, or you don't have to, okay? But you need the 2 triangles. So I think it would be best that we get a good chunk of work time